A Basic Introduction to Propositional Logic, Demonstration 4.2, Arrow in. A conditional is symbolized by the arrow symbol, and the pieces it connects are called the antecedent and the consequent. It basically means if-then. If is the sufficient wording, and it attaches to the antecedent, which will come before the arrow. The wording's only if flips the order, and it will become a necessary conditional, and the only if attaches to the consequent, which basically comes after the arrow. The arrow in rule uses an antecedent, so the first part before the arrow. It could be a provisional assumption, and it derives a consequent. So it uses many steps as it takes. Once you do introduce a provisional assumption, all the assumptions have to be marked in assumption dependency column. Problem 70. We will only have the party at Nadia's house if her parents are gone. If her parents are gone, we kids can drink as much as we want, and if we can drink as much as we want, some of us might get sick. So if we have the party at Nadia's, some of us will be sick. Step 1, find the code words. So they're capitalized for you. N will stand for there's a party at Nadia's. G will stand for the parents being gone. D will stand for drink what we want. And S will stand for get sick. Step 2, symbolize the relationships. In the first statement, this is a little bit tricky because the only if points to consequence, which come after the arrow. But this one is broken up. So if you see we will only have the party at Nadia's, you might think we'll only Nadia's house. So you might put Nadia after the arrow, the N after the arrow. However, notice the only if is broken up, and you have to trace it and see that it's only if her parents are gone. That's how you know that the G comes after the arrow, because only if points to consequence. So this one is broken up. You have to trace it to find what it attaches to. Second statement, if her parents are gone, we can drink as much as we want. This is a simple conditional, right? G, arrow, D. Then the third statement, if we drink, then we might get sick, D, arrow, S. The fourth statement, the so tells us that it's probably the conclusion. So if we have the party at Nadia, some of us will be sick. And then we have N, arrow, S. It just ends in another conditional. So taking those pieces, we formalize our sequent. N arrow G, G arrow D, D arrow S, and then the conclusion is N arrow S. The premises, remember, are separated by commas. The conclusion is after the turnstile. Now, step 4, setting up the proof. Remember, we always put the assumptions at the top. The assumptions from the premises that you bring in, they're called assumptions in the proof. So N arrow G, G arrow D, D arrow S, those are placed at the top. Those are all assumptions. They're given to us, right? They're justified by just them being assumptions that are given. Then we have N arrow S. That's the conclusion. We place that at the bottom because we are not sure how many steps it's going to take us to get there. Once you set up the proof, you want to look at the conclusion and say, well, how do I get there? How do I get N arrow S? The first thing you should notice is what kind of statement it is, right? So sometimes you have a conjunction, a disjunction, etc. In this case, you have a arrow, right? You have a conditional. You have N leading to S. So that's important for you to note. Next, you want to solve the proof. So again, let's look at this step by step. It's a little bit longer. The conclusion is an arrow. So show how N will lead to S. So you will use arrow in. That should tell you, okay, I need to use arrow in for this proof. So how do you do arrow in? You start with N and it will lead you to S. So put those in. You know you need N at the top, and then you know you need to get to S at the bottom. And the middle lines can be blank because you're not exactly sure until you get there what you're going to do with those, right? Now, do you have N anywhere in this proof? So look at the 3 assumptions you're given. I mean, there's an N in line 1, but it's trapped in an arrow. You can't just pull it out. So you have to just assume one, right? In this case, since you don't have N, just introduce it as a provisional assumption. This is what we call a provisional assumption, meaning temporary. Now, once you have a PA, a provisional assumption, that triggers the AD column. That's the column at the very front of the proof that has a bunch of numbers in it. Remember, a proof has line numbers, your formulas, and your justifications, so you add another column at the beginning called the AD, or assumption dependency column. This is where you keep track of all assumptions. Through a series of arrow outs, you can get to S. So now that you have N on line 4, well, you know that from line 1, it says if you have N, you'll get G. So then you can just do arrow out, right? You get the G on line 5 by just saying, well, line 1 has a conditional, and then line 4 gave me the antecedent, which is N. Therefore, I can get the G. Same thing for line 6. How did we get the D? We just used arrow out. We have the arrow on line 2. And because we have the beginning part of it on line 5, we have G. We can just take out the D and we're left with just D and taking the arrow out on line 6. Then we have the same thing for line 7, right? We have D leads to S on line 3, and then on line 6 we have that we did get D, so we can just take out the S, and we have S using arrow out lines 3 and 6. Okay, finally, we have shown now that if we were to introduce N on line 4 using our own provisional assumption, then we can get to S by line 7, and that's what we call arrow in. This is where you say, look, I've introduced N, and using N, it led all the way to S by line 7. This is a multi-line rule, so you're not always sure how many lines it will take. However, it takes from the beginning of the arrow, the N, from the antecedent to the consequent, which is S. That's how many lines you put in with a dash. So 4 through 7, arrow in. So again, for your justification, show which lines led from the antecedent N to the consequent S. For the AD column at the front, right, at the beginning, the first column of the proof, know that all assumptions depend on themselves. That's how we're getting for line 1, which is labeled as A, an assumption, you just have 1. Line 2 is just depends on itself, line 2. Line 3 is an assumption itself, right? So it depends on itself. It doesn't need to depend on anything else. Remember, we're only keeping track of assumptions. Line 4 is also labeled with an A, but it's a PA, right? It's a provisional assumption. So notice lines 1 through 4 are the only assumptions in this problem. You don't see A anywhere else, and so the only numbers you're going to put in the AD column are going to be 1, 2, 3, or 4. Those are your only choices. So that's how we got lines 1 through 4. Then look at line 5. On line 5, it says we used 1 and 4 arrow out, right? Are 1 and 4 assumptions? Yes, they are, so we put them there. On line 5, we say 1, 4. What about line 6? So remember, all assumptions depend on themselves, but for the other lines, use the justifications, right? Use the column that shows how did we get that line to find which assumptions those used. So for line 6, we have that we use lines 2 and 5, arrow out. Okay, let's check 2 and 5. Now we've already done a bunch of those lines. Just look at the top and go to the AD column. Line 2 is based on 2, 5 is based on 1 and 4, right? So we just put those there for line 6. We say 1, 2, 4. Line 7, done in a similar way. We say, okay, it was 3 and 6. Okay, let's look at what we already calculated for 3. Line 3 rests on 3. Line 6 rests on 1, 2, and 4. Therefore, you get 1, 2, 3, and 4 by line 7. Okay, line 8, it uses lines 4 through 7, arrow in. So scanning those rows, 4 through 7, what numbers do you see? Well, you see that it contains 1, 2, 3, and 4, right? That's what should be there on line 8. However, notice that we don't have number 4 there. Why is that? Because arrow in is one of 3 rules that can eliminate an introduced PA, a provisional assumption, right? For the deeper understanding for why that is, refer to the textbook, but just so you know, that's the rule. Arrow in is one of the 3 rules, okay? We'll learn other rules later, which also can eliminate PAs, but arrow in is one of them. That's why we don't have to put 4 there. It eliminates the PA, and we're left with just 1, 2, and 3. So in this case, the conclusion rests on only original assumptions. That is the point of the AD column, to make sure that your answer at the end, remember, the provisional assumption is a PA. PA is a provisional assumption, meaning it is temporary. You cannot keep it. You can't just introduce it and just leave it there. So by the end, you have to get rid of it. And in this case, arrow in will get rid of the PA. Here's the final answer of the entire sequent and the entire proof given.